Hello, my name is Prerna, and I'm a medical imaging intern at Sunnybrook for the summer of 2025. During my time at Sunnybrook, I worked on an image registration project focusing on the registration of pre-ablation contrast-enhanced, or LGE, MRI images with the post-ablation LGE and post-ablation non-contrast T1-weighted, or NT1 images for improved alignment to create more accurate scar predictive maps to potentially identify corridors where ventricular tachycardia could originate. I'll be going through a brief walkthrough of the platform I use called 3D Slicer, and specifically focusing in on affine image registration from the brains module for the various image volumes that I'm working with. And I'll also go through the quick overlay function on 3D Slicer, saving and uploading. First, we've saved all the DICOM files for the pre-ablation LGE, post-ablation native T1, and post-ablation LGE in 3 separate folders. Then we go to our DICOM data and load it. Since I've had it loaded already, I can access it here in the DICOM database, as you can see. And loading each one takes some time, but once you've made the upload, it'll be stored in your database where you can access it whenever you want and as you need for the project you are working with. Once you can access your different files, you can view it and experiment with a variety of tools that Slicer offers for visualization. So you can just click on this eye icon right here to get an initial view. And then you can go to the view controllers drop down and see the different slices of each of your views. And the 3 views presented are the axial, coronal, and sagittal views. If you want to analyze a particular view closely, you can double click it and view it. You can also click this link icon right here and link all the views. And if you want to alter the different slices, you can use this slider over here. The link icon essentially means that if you change anything or add anything to this one, it'll apply to all of the other ones as well. So if you use this drop down right here and add an overlay, it'll apply to all the views. So add an overlay image, it'll lay on top of this view and this view, even if you just do it for the axial view. You can view this eye right here, and this will show it to you in the 3D view. So this right now shows all of them because they're kind of linked together. But if I unlink them, and then I can just view a single view depending what I want on the 3D plane. And if you look over here for the 3D view controllers, there's all kinds of different tools you can use to do whatever you want in terms of altering or manipulating 3D view. So you have the zoom in or zoom out, and you can also do some spins if you want. This is a full 360 spin or 180, just back and forth. You can also add an orientation marker. So whatever you need to do to accomplish the goal of your project. It's also useful to know that you can choose or customize how you visualize the 4 views by going to the view tab over here and clicking layout, and you can see all these different kinds of layouts you can use, and it allows you to change up the organization and general appearance of what you're looking at. And if something changes and you just want to reset it to the standard view, you can go to the same tab and to the appearance section and then just click reset to default. So yeah, this is the default, and it'll set everything back to the standard settings. For this particular project, we worked with 3 main registration modules: Brains, Ants, as well as Elastics. Brains is a built-in module. However, Ants and Elastics have to be accessed through the extensions feature, which you can find here. And to just give you a quick visual of how the registration works prior to any cropping, that'll be for later, we'll perform an affine registration technique for pre-ablation LGE MRI and post-ablation LGE MRI on brains. So first we're going to figure out how to navigate to the brains module. So we're going to go to the registration and then hit the brains module, general. And then as you can see, the fixed image volume is the pre-LGE. The moving image volume is the post-LGE. Percent of samples is 0.1, that's 10%, and it's the amount of voxels of the fixed image used for registration. You can also see the initial transfer mode is use moments align, and that is what we've generally just always used for all of the registrations we've worked with. And also important to note, the slicer linear transform, that is the linear transform node, that is the output of this registration, of this affine registration. So it's really useful if you want to use it as an initial transform node for other registrations like pre-LGE and post-native T1. You also have the output image volume over there, which is just the output volume of the registration. We have the registration phases, which is just affine 12 degrees of freedom, and that's one we're working with right now. And you can also go to the expert only parameters and change up the cost metrics. So we use normalized correlation and mutual information histogram for our various registrations as well. So depending on whatever works. So that is kind of the whole layout, and you can apply it. And typically affine is quite fast. It'll typically take like 5 seconds. So that should run. And once it's run, as you can see, it's not meant to be perfect at all, just to prove the concept and show you how the registration would go through. So yeah, that's typically how registration works on brains. It's pretty simple, and you can view it here over in the data tab. That's the node over there, so you can edit its properties if you want to change things up. You can even add it as a transform to a mesh. And yeah, that's your data right there, and you can view it, view the output volume as you require for whatever purposes. To improve the results of registration, one of the methods that helped us was cropping. In 3D Slicer, you can use the crop volume module to try and crop the different images you are working with to focus in on key features or anatomical structures. Without the cropping, for us, the registration results were kind of dominated by the chest wall, the white representation, instead of the heart. So the crop volume helped us navigate this issue. In 3D Slicer, you can use the crop volume, which we'll just quickly navigate to. So you can actually just probably search it up here, switch to the module, and as you can see, the input volume is going to be the 3D LGE, pre-LGE, and you can just create a new ROI, which is your region of interest. And you can rename that as well. I'm just going to keep it for the sake of demonstration. And you can basically just manually manipulate this bounding box right here to fit whatever crop you want. So you can use the view controllers tool and visualize all of these views on the 3D plane, or you could just alter the crop just using the 2D views. So I'm just gonna leave it at that, and then once that's over, you can just create your new output volume. I'm just gonna create a new volume and rename it later. Keep the interpolated cropping for this purpose and apply. So after clicking the apply button, you just go to your data, and you can just I'm just gonna close that, and it'll be right under the pre-LG section. As you can see, that is the cropped volume. So that's how you crop. So I did the same thing with the post-LGE as well. As you can see, it's also cropped. And now, since the extents match on both post and pre-LGE MRIs, we can just run it through a sample registration. And let's run it through brains affine registration, the same one we used before. So we'll navigate to that. And as you can see, all the things that we kept are the same. I just changed up the percent of samples to 0.5. So now it's using 50% of the voxels in the fixed image for registration. And I also renamed the output image volume to post-LGE plus pre-LGE cropped affine. So now we're doing cropped, and a linear transform has also been saved, and this is important because I want to use it as an initial transform, the node that results from this, for my pre-LGE to post-native T1, which will maybe be explored a little bit later. So let's just do that, and everything else is kept the same, including affine with 12 degrees of freedom, as well as the cost function, which still remains mutual information. So we're just going to apply this. We also changed our fixed image volume and moving image volume to the cropped versions. So as you can see, we have a result, and this is our cropped version. And you can also access this in the data tab. So you can just that, and as you can see, that is your result from the affine registration crop. Before we move on to the registration of the cropped pre-LGE MRI and the native T1 weighted images, I just want to mention that when we performed image registration with the pre-LGE and post-native T1, we did recrop the pre-LGE once we learned that the old cropped LGE, the one that you saw, actually doesn't provide a realistic registered result, although it did look nice and provided somewhat of a good visual overlay. And this is because the post-native T1 volume only covers the ventricles of the heart, while the LGE volumes include the atria as well. So that resulted in stretching that became unrealistic. So when recropping, we used this reference image to cut out the atria and align the native T1 as best as possible based on the weight aligned with the post-LGE, which is what you see in the image. Yeah. Let's take a quick look at the registration process with the newly cropped pre-LGE and the cropped native T1. So cropped native T1, cropped LGE. As you can see, the H have been cut out. And I'm just going to stick with brains, affine. So I'm going to go to brains and affine, and everything is saved, all the things that we had set from last time. But the only difference here is, as you can see, and I've renamed the output image volume, but I had an initial transform, and that is the same linear transform node we saved earlier from the affine registration with the pre and post LGE to use as an initial transform for this registration. And the main reason why that idea popped up in the thought is because of the fact that the post-native T1 weighted MRI has lower contrast in the heart compared to the pre-LGE, so registering it with the pre-LGE image does not yield the best possible result. And this is why we'll perform the pre-LGE and native T1 registration with a transform node from the pre-LGE and post-LGE registration, since they provided better results, being both contrast images and cropped. So yeah, as you can just see, this is the pre-LGE, obviously more contrast compared to the non-contrast method, the native T1. And so that is the reasoning behind that. So we're just going to quickly go to brains and run this registration. And obviously our fixed and moving volumes have changed in reference. Before we get into the manual overlay, I want to mention that there are definitely other tools such as the checkerbox module as well as the color overlay that can provide other ways of determining how well the registration works out. There's also quantitative methods such as the dice similarity coefficient, which can provide more quantitative-based measurements on the effectiveness of the registration by comparing the segmentations of the registered volume and the fixed volume by providing a statistical measure. And that would use the segmentation comparison module in Slicer and requires both volumes to have segmentation meshes that are exported as label maps. So now we will go through the manual visual overlay. So this is a quick and easy tool that you can use within the View Controllers tab that allows you to essentially lay the registered image on top of the original fixed image or any image on top of another for convenient viewing on how well aligned the images are. So as you can see, I've set the kind of bottom image to the fixed volume, so the pre-LGE cropped, the first one we had, and the top is going to be the result of the registration between the pre-ablation LGE and the post-LGE. So this is not the one that we recropped, and so that's going to be the top. And so you can use the vertical slider on the left to try and see how aligned it is, and this is just manual overlay to see how well the registration worked. It's very qualitative in nature. And as you can see, if you just kind of do it, you can get a little visual on that. You can even add color to help you distinguish if that makes things easier. We can also do this with the result of the recropped pre-LGE and post-native T1 and align it with the recropped pre-LGE as the fixed image volume. As you can see here, it's the recropped pre-LGE, and we can just put this as our image to lay on top. Since affine obviously provided the best result, we're using that as the registered result to use for the overlay. And as you can see, you can use this vertical tab over here to do the same thing. Obviously, this is not as well aligned just from this overlay, and you can definitely resort to more quantitative evaluation tools to also see how well the alignment worked. One of the most important parts is saving your scene and files on Slicer. At the top left-hand corner, you'll see a save button. So start by clicking that. And then you'll see an MRML file, which consists of the scene you're working with as well as all the individual files. You can customize or select the folder you would like to place them in or create a new one depending on how you want to organize everything. So you can just either create a new one in the files application by clicking that and just creating a new folder, or you can just create the folder separately in the application, in your folders application, and then just manually add it. So if you want to put different files in different folders, you can just manually do that as well. So however you want to organize things, Slicer is flexible. For uploading files, you just have to click this data button if it's not a DICOM file. So when you save it, a lot of the times it won't be of the DICOM file type. So you can just either choose files to add just from your folder, or choose a directory that you want to add. So that gives you two options, and once you load it, everything will just be available for you to view and use for anything you need on Slicer. Also, pro tip, I did learn this the hard way, unfortunately, but make sure you consistently save your scene as you work on Slicer, because if your computer restarts or shuts down, all your work will be lost, so better to be safe than sorry. Before I end the walkthrough, I would like to thank Bonnie, one of the most reliable and inspirational people I know. Terrence, so incredibly kind and knowledgeable, Graham, the coolest PI and leader, Jennifer, the heart and joy of the team, for a truly wonderful summer after senior year. The team truly made the experience as amazing as it was, and I always found myself learning something new or experiencing something new. And Sunnybrook is truly a place of growth and passion, and I'm just so grateful to be part of this innovative and impactful community. So thank you very much, guys, for this amazing experience.